Hello everyone, you are welcome to this class. In this class, we want to continue our set theory. Today, we want to look at further problems on set builder rotations. So not only this, after this, we're going to look at Venn diagram. So Venn diagram will be our major focus in this video. So we have this example. So the first example is if universal set is x such that 1 less than equal to x and x less than equal to 5, and its subsets, I've explained what subsets are. So which means subset P and Q, all the elements in P and Q must be what included in this. So it's not go beyond this. So that's what it means. So P is even number, Q is multiples of what? 3. Am I with you? Multiples of 3. This is 15. Multiples of 3. So draw a Venn diagram to show this information, and hence find the following. We want to find P complement, P union Q, P intersection Q, P complement, P union Q complement. So before we do anything, let's interpret this set builder notation first. So the first one, solution here. So we're going to have the universal set, which is x is less than or equals to 1. So that means x is greater than 1 and also equals to 1. So 1 is part of the answer. That's meaning. Then x is less than equals to what? 15. That is all the numbers that are less than 15 and also equals to 15, which means it is from 1 to what? 15. So 2, 3, 4, 5, 6, then to 15. Alright, so that is the universal set. Then set P, the element is even numbers. That is even numbers that we have here, because P is a subset of what? Of the universal set. So all the even numbers that we have here, we write them as that is 2, 4, 6, 8, 10, 12, 14. Alright? Then Q is multiple of 3. Multiples of 3 that we have here, we write them out as well. That is 3 is a multiple of 3, 6, and then 9, 12, and then what? 15. All these numbers are multiples of 3. Now, but the question asks us to draw a Venn diagram to show this information and hence find it. So that is, we are going to draw a Venn diagram that will show this information. So our Venn diagram, we have this. We have the rectangle. The rectangle, as I've explained, is the one that is talking about the universal set. So while the one circle, the circle there, we only have 2 sets, P and Q. And before we draw the 2 sets, we must check if we have elements that belongs to P and also belongs to Q. So that if they have intersection. So that's what we're going to look at first. 2, we have 6. So 6 is common. 12 is also common. So in that case, we are going to intersect the circle. So this is P and this is what? Q. So the first thing is to list the intersection, which is 6 and then what? And 12. 6 and then 12. Up and with you. So that's the first step. So after that, we're going to put the remaining elements in P here. So 2, 4, 6 is here, then 8, 10, 12 is here, then 14. So these are the elements in P. So we go to Q. 3, 6 is here, then 9, 12 is here, then 15. Alright. Now, the next stage is to compare what we have here with the universal set. Now the first thing is that we don't have 1 here, and there's 1 universal set. That will be outside the 2 circles. I hope I'm making sense. 2 we have 2, 3 there, 4 is there, 5 is not there, we have 5. You can write it anywhere. 6 is there, 7, we don't have 7 in any of the 2 sets. So 7, then 8, we have 8, 9, we have 9, 10, 11, we don't have 11 to be out. 12 is there, 13 is not there, 14 is there, 15 is there. So that is that. So we check. So we are going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, which covers the universal set. So this is the universal set here. So we have answered the first question, which says draw a Venn diagram to show this information. So that is that. We are done with that one. So the next is that the question now says that we should find Q complements. Q complements. So we want to find the complement of Q. That is all the elements we have in the universal set that are not in what? In Q. So that's what we want to list out. Now we list that one out. So we have in the universal set we have 1, we have 2, 3 is here. So 4 will also be part, 5 will also be part, 6 is here, 7 and 8, 9, then 10, 11, then 13 and then 14. So these are the elements that are in the universal set that are not in what? In set Q. So that is that in that one. B, so we have to find P union Q. P union Q. P union Q. We're going to combine these two without repeating an element twice. So the first one is we have 2, 3, and 4. We don't have 5 in both. So 6. We don't have 7. We have 8, 9. Right? Then 10. We don't have 11 in both. Then next is 12. We have 14. Then we have 15. Then we close this. So that is P union what? P union Q. So the next one is P intersection Q. P intersection Q, which we have found when we were drawing our Venn diagram, and that is 6 and 12. 6 and 12. How about that? D. D, you want to look for elements we have now, P complements. P complements. So that means elements in the universal set that are not in what? In P. So let's look at this. So 2 is here, 1 is here. So we have 1. We have 3. That is 3. Going to be 3. We don't have 3 here. 4 is here. 5 is here. There's no 5 here. We have 5 here. Then 6 is here. 7 is there. Then 8. The next is 9. So we have 10, 11, 12, then 13, then and what? And 15. So that is P complement. So the next one, which is E is P union Q. P union Q complement. P union Q complement. So we found P union Q. This is P union Q here. Alright? So we are now going to compare it with the universal set. That is all the elements we have in the universal set that are not in P union Q. So that is what we want to do for now. So what we're going to have, so in P union Q, we have 1 here, we don't have 1 here. So we have 2 here, we have 2 here, we have 3 here, we have 3 here. 4 here, 4 here. 5 here, no 5 here, we have 5. Alright? 6 here, 6 here. So there's no 7 here. There's 8, 9, 10, then 11 is the next one. So we have 12, we don't have 13. We have 14 and 15, so it will stop at 13. So that is that on Q complement. So what we are going to look at, that is that on problems on Builder notation. So the next thing we want to look at how to use Venn diagram to solve problems. So we are going to look at 2 aspects. We are going to look at where we are going to have 2 sets and where we have 3 sets. So that's what we're going to look at next. Alright, using Venn diagrams to solve problems. So we're going to start with 2 sets, where we have 2 sets. Now in a class of 40 students, every student had to study French or Russian or both subjects. So 25 students studied French and 20 studied Russian. Find the number of students who studied both languages. So this is for two sets. So what we're going to do, we're going to interpret this first before we use Venn diagram. So we interpret using set notation. So this means that number of universal sets, since the total number of students in the school in this class is 40. So that means the universal set, the number of universal sets is 40. No, we are not listing out elements. We are looking at number of. Then we have French. We can make French to be F. So number of students that study French is 20. 25 students studied French, 25. Why 20 studied Russia? Number of Russia is 20. So don't be surprised that when you add these two together, it will give you more than number of students we have in that class. Don't look at it that way, because that is where students usually get confused at how come we have number of students that study French is 25, while the number of students that study Russia is 20. And we are saying that we have 40 students in the class. So which means this is more than 40. Yes, it's more than 40, but you don't have to look at it that way. There are some of the students that study French that also study Russia alongside. So all of them have been calculated together to get 25. And there are some of those students that study Russia and at the same time study French. Everything is inside this 20. So you understand by the time we start looking at it now. Now the question asks us to find the number of students who study both languages. Now the best way to solve this is to use Venn diagram. So using Venn diagram, we'll be able to see it clearly. So let's have the Venn diagram here. Since we have two sets, we are going to have two separates. And the question asks us to find number of students that study both languages. That will be F and the what? And R is what we are looking for, which is X. So which means there is intersection. That is, the two circles here will be intersected. Right? So we're going to have it here. So this is French. This is what? Russia. Anytime you are given problem like this, you are going to start, whether two sets or three sets, you must start with where the three or where the two sets are meeting before you start fixing your figures. You start with where the two sets, if there are two sets there, are meeting, or if there are three sets, where they are meeting is where you start from. So they are meeting at this point, and that is given as what? X. Now, the F, the circle of F is what? 25, because total number of students that studied French is 25. You know I said it. So that means if you put 25 here, you are saying total number of students that study French only without studying Russian. But here, they did not tell us that French only. 25 students study French only. There's no only there. So if you put 25 here, you'll be wrong. So that means that the total number of students that study French all together is what? 25. You know, you are in a class. Some people might be studying French, some will be studying Russian at the same time. They will be studying both subjects at the same time. So that's why we have X here. So in that case, this will then be what? This place will then be 25 minus what? X. That is, we are going to remove the students that are studying Russia and also studying French. We remove them out. So what we have left here will be what? French only. Exactly. Why this one is what? French and Russia. Then move to this side. So number of students that study Russian is what? 20. Why out of the 20, this one is going as X. So this will also be what? 20 minus what? X. How are making sense? Now, since the universal set here is what? 40 equals what? 40. That means addition of everything here is what? 40. That means we're going to have 25 minus x plus x, this plus this plus this, plus 20 minus x equals what? 40. So let's now see what we're going to have. Minus x plus x will give us 0. 25 plus 40 will give us what? 45 minus what? X equals what? 40. I hope I'm making sense. So in this case, what we are looking for is X. We can just take X to the other side and bring this one. That will be 45 minus 40 equals to X. So therefore, X equals to what? 5. That is number of N. So because we find the number of students who study both. So the number of students, thereby the number of students that study both languages is what? Is 5. So that is that on that. I hope this is very clear. So the next stage now is to look at 3 sets. So we looked at 2 sets. Now, what we have here, a group of restaurant owners in a town sell at least one of pounded yam, gari, and amala. That is 3. So which wants to solve this? So we are going to represent each of these one with letter, right? So we come into that. 25 of them sell pounded yam, 30 sell gari, and 20 sell amala. So 6 sell amala and pounded yam, 9 sell pounded yam and gari, 5 sell amala and gari only, while 4 sell all the 3 items. How many restaurants are there in this town? Without Venn diagram, you'll not be able to solve it. So let's see how we can do this. Now, which means how many restaurants are there in this town? That is, so in this case, we are looking for a universal set. That's what we're looking for. So in this case, so let's have, we have 25 of them sell pounded yam. So let's pounded yam, number of pounded yam be 25. Alright, 30 sell gari, number of gari is 30, and the number of amala and 20 sell amala. So that is A is what? 20. Now 6 sell amala and pounded yam. So number of amala and pounded yam is equal to what? 6. 6 sell amala and pounded yam. 9 sell pounded yam and gari. So number of pounded yam and gari, pounded yam, 9 sell pounded yam and gari, that is 9. Then 5 sell amala and gari only. Please take note of this. Only is there. So if you forget to take note of the only, you miss it. So that means number of amala and gari only is what? Is 5. Hope I'm making sense. While 4 sell all the 3 items. That means number of amala and gari and pounded yam is what? 4. So having interpreted this, so the next is now to come up with a Venn diagram. Alright? So we have a Venn diagram like this. This is a Venn diagram here. Right? So we have 3, so which we are going to have 3 circles. And the 3 circles, so this is the universal set. We don't know, we are not given. So we're going to have this, we're going to have this, I'm going to have this. So we have pounded yam, gari, and then what? Amala. From what I told you, when we were looking at 2 sets, I said, excuse me, if you want to start this, you start at the middle. You start at where the 3 of them are meeting. Where are the 3 of them meeting? They are meeting as 4. That is 4 owners sell amala, gari, and pounded yam. So we go to 4, where we have 3 of them are meeting at this. This is amala, this is pounded yam, this is gari. All of them will be here. That is 4. So after 4, we go to the one of 2, 2. So 2, 2. So number of amala and pounded yam. Amala and this is amala. This is pounded yam. This is the type of pounded yam. So amala pounded yam belongs to this area. Alright? And we have seen 4. Amala pounded yam is what? 6. So which means pounded yam and amala only will be what? 2. We add these two together, will give you 6. I hope that is very clear. Then pounded yam and gari. This is pounded yam. And this is what? Gari. It is how many? 9. And this is 4. If you take 4 out of 9, it will remain what? 5. That is pounded yam and gari is what? 5. Then the last one. Amala and gari only. Amala and gari only. This is only. So that's why we are only looking for this. This is what? 5. So that's all. So the next is now to look at 1, 1, 1. What will be pounded yam only? What will be gari only? What will be what? Amala only. So the next thing to do now is to find P only, G only, and A only. So to find P only, so number of P only. So P only, the total P is 25. And this is already out of it. So we are removing 5 for all this. The 7 that belongs to P is 25. So this one is out, this is out, and this also out. That is 5 plus 4, 9, plus 2, 11. So that is going to be 25 minus what? 11. That gives us 14. So which means this place is what? 14. Then for G only as well, number of G only. G only. Alright? Will also be G, the total of G is 30. Alright? So that means 30 minus 5 plus 4 plus this becomes what? 14 as well. So this, when you subtract this one, it will give us what? 16. So which means this place was 16 only. I hope I'm making sense. Then it remains number of A only. A only. A only. A is what? 20. So we subtract minus 5, that is 11. Minus 11 as well. And this will give us what? 9. So this replaces what? 9. So the next stage is now to, so because what we have to find is how many restaurants are there in the town. So we are going to add everything that we have there. We give us our total. We give the total. So in that place, we are going to have number of universal set now. Is what we are looking for. And that's going to give us, we have 14 plus 5 plus 16 plus 5 plus 4 plus 2 plus 9. If you count 1, 2, 3, 4, 5, 6, 7. So the same thing here, 1, 2, 3, 4, 5, 6, 7. Let me add everything together, and that will give us 14 plus this is 19, 19 plus this, that is 20, 20, that's 35, 40, 44, 46, and then that is 55. So which means there are 55 restaurants in the town. So that is that on that. So that is that on this video. This is where we're going to stop here. So if you are new to this channel, don't forget to subscribe and make sure you turn on your notification bell. So anytime I produce video like this, you'll be able to have access to it. And if you find this video useful, don't forget to give us a very big thumb up. So we are going to meet in our next video. Bye for now.